Why you shouldn't hide your data. By the end of this episode, you're going to understand the benefits of having your data exposed to the world, why functional programmers like it that way, and how to avoid some of the major pitfalls that you might come across if you do that. And I kind of want to end with a process that you can use that will help you design your data. Hello, my name is Eric Normand, and I help people thrive with functional programming. This is important because this is one of those very significant philosophical differences between object-oriented programming and functional programming. So it's worth digging into and emphasizing it, spending some time there. Okay, so the first idea that I think it's important to understand, if you're an object-oriented programmer, you might be wondering, why don't you want to encapsulate your data? Isn't that a good thing? And so the question is why would you hide it in the first place? Why would an object-oriented programmer hide it in the first place? In the object-oriented world, you basically have a bunch of mutable state, and instead of having it sort of all grouped together and living in this big soup of mutable state, you say, hey, I'm going to take this little piece of mutable state, one little chunk of it, wrap it up, and use the methods on that object. Wrap it up in an object, so you can't directly get at the state. And I'm going to use the methods to ensure that the state is kept consistent. Okay, so you might have two values that have to be kept in a very precise relationship. So if I change one, I need to change the other, right? So you want what you're doing is you're creating a level of indirection that does not allow them to get out of sync. And so the person or the programmer writing to that interface doesn't have to worry about them getting out of sync anymore. They can put that out of their mind. It's compartmentalized, it's modular, it's wrapped up. Okay, that's the main reason why an object-oriented programmer wants to not have direct access to the data. Now, they need the data at some point, right? They need to know what those pieces of data are, but they have to ask. And by asking through this interface, it allows the consistency. Functional programmers typically are either not using mutable data or very sparingly are they using mutable data. So a large part of that problem goes away. We just don't have the same scale of problem that requires that kind of encapsulation. If your data isn't changing, once you create it, it's fixed. And so you can just create it in the right relationship and then you're done. You don't need to hide it. You don't need to encapsulate it. Now, it might be very useful to go and talk about what data actually is. If you look in the dictionary, it'll say that data is facts about events. So something happens and you write it down. You write down what happened. As much as you want about that thing, right? The user bought this shirt, right? Or even more precise, the user clicked the buy button on this shirt, right? Or the thermometer said 25 degrees, right? That's at this time, right? So it's an event that happened. We got a thermometer reading. That's the event. We wrote down some information about it. It's a fact. Okay. What is the current value of the thermometer is different from the value of the reading, which is why we can say it's immutable. At that reading, this is what we got. Doesn't matter what it is now, right? This is what we got at that time. There's a certain structure to that data, and that structure is also immutable. And what functional programmers like to do, especially since what functional programmers like to do is just leave it as data. Do not wrap it up. Do not make a new API to talk about this data or to manipulate this data, to read this data, because we're not modifying it. Do not make a new API. Just let it be itself. Let it be this piece of data that can move from context to context, and that context determines how they want to read it. So in one context, you might interpret, let's say, the temperature and think of it as you want to classify it into, t-shirt, long sleeve shirt, sweater, or jacket weather. Okay, so you bucket it into those categories so that you can tell the user, what to wear that day. Another part of the system would use that same bit of data and say, well, I'm collecting these things and I'm going to show a graph over time of the temperature. And then another part of the system might say, well, I'm going to just record how often the temperature gets read. So I can just make sure, like a monitoring service, make sure that we're getting frequent enough temperature readings, right? So these are all valid ways to interpret that same data. The fact is the same. At 3 p.m., the temperature was 25 degrees. But the usage is different. And so we want to keep it kind of as raw and factual as possible so that it can be as useful as possible to all these different contexts. In an object-oriented world, just to contrast it, not to say it's bad, but in an object-oriented world, you would need to deal with all of these contexts. And typically, you would say, well, we're just going to add methods to that temperature reading class, and that reading might be, converted into what you should wear. Is it a jacket weather or is it t-shirt weather? Another reading might be some way to turn it into an average, right? Another method would be turn it into an average. But typically what happens is this class has to service so many different contexts that what you wind up doing anyway is just putting a getter that just says get the temperature. And then those contexts just read those getters, right? So it doesn't really have any functionality. It's not really protecting anything. It's just giving you the data. Now, if you're just going to do that anyway, you might as well just expose the data, right? Just let it be exposed, just be visible all the time. Because then if it's just reusing an existing data structure, then you already know you don't have to learn a new API. You already know how to access that data structure. Okay, so this is one of the objections that functional programmers have is you're creating this new API that I'm forced to use in all these different contexts. And at the end of the day, you need a backdoor. And so you put all these getters on there just in case the API isn't complete. And then, but that's what people wind up using anyway. And so it doesn't really make sense to go this roundabout way. In practice, what I've found, this is my experience, is that the contexts should the contexts wind up defining their own operations on the data themselves in a way to interpret it. So instead of having some like abstract universal API for this piece of data that is useful in all contexts, the only thing that's really useful in all contexts is just getters. Okay, so then you have each context having its own interface, which determines how to interpret that data. Okay. All right. I think I've really churned through that pretty well. We just treat it as data, and so different languages do it in different ways. In Clojure, we tend to use a lot of maps with keywords as keys, and then the values in the maps, the data values, are in the values of the keys. So we use the keywords to name the values, and that gives it the structure, right? It's key value pairs where the names are sort of well understood among all the contexts. So it's just getters. I mean, don't get me wrong, it's just getters, except they are not custom for each piece of data. It's still a hash map. You can still do what you need to do, like what you would normally expect a hash map can do. So you can list all the keys, for instance, right? You can put the keywords into an array, right? So now you can say, or a vector, you can say, I only care about these 4 keys. Give me a map that just has those 4 keys in it, right? And this is an operation called select keys, as opposed to an object that that's a custom and bespoke just for that one type, just for that one, usage, that one concept. That class does not participate in all these other operations that are common. So you've lost out on this opportunity to really be a deeper part of the ecosystem. Okay, I don't want to beat that horse too much. We just like to leave things as data. Now you have Haskell, which you typically would define a new type. They don't use hash maps the way we do in Clojure. You would define a new type to represent the thing, and yet that type is still totally exposed. Once you know the type, you can get all the data inside. It's just available. And so they get in Haskell, you get more leverage from the type classes that can be automatically derived from the data, like a reader and a printer. Okay, so here's the thing, though. Even object-oriented programmers nowadays are already doing this, and you can tell that they've been doing it for a while, and I don't want to go too deep into like the object-oriented programming, but you yourself are probably already doing this. When you call an API endpoint and you're passing in JSON or XML, that's just data. That JSON that you send or that you get back, that's just data. It's not an object with methods that are hiding your data. It is a piece of data. It's raw. And it's, in a sense, it's immutable because it's a copy. The server serialized you a big JSON value, and you deserialized it into your own memory, and it's a copy. Changing this thing is not going to change what's on the server. So in a sense, it's immutable. You know what the server told you, and that's the event, right? This is what the server told me to this request. I have a fact about it. This is what it is. And now, you notice a lot of like enterprise Java systems tend to serialize things a lot. Serialize things to XML, and then even sometimes read it directly back in, which is kind of weird. But when you look at it from the perspective of they're making copies of data, and what they really want is the data itself. They don't want all this interface around it. They're going to serialize it and read it back in again. That's there's something going on there. There's a reason they're doing it. And it's very expensive to do, but they want the immutable data. They want the ability to just get at the raw stuff. Okay. What the thing is that functional programmers, how do I say this? They want to have that same feeling of like, oh, I called this method I called this endpoint and I got the JSON back and I just have the data. They live in that all throughout their whole system, not just at the API boundaries. They're always there. They're always dealing with data. Okay, Haskell's going to be much stronger typed when you're within the language and not reading in random JSON from around the internet. You got much more control and knowledge of what each type is. But you're still just handling data. You're converting data from one format to another, from one structure to another. It's data, and it feels nice. It really does. Okay, so benefits. The first thing is you don't have to write all those getters and setters. I think that's huge. You're going to write them anyway. Why not just make that how you access the object, right? As like the baseline, right? And you can defer writing all this huge interface until later when you understand the context more and you're really just starting to find how you're going to use this piece of data and then codifying that into some functions. Another thing is when you're using the data structures that come with your language, they've already got printers, they've got readers. This is if you've got a decent language. So, for instance, if you're using just objects and arrays and numbers and strings in JavaScript, you can just serialize that to JSON when not even thinking about it, right? And then read it back in, not even thinking about it. It's just one function call. If you've got a custom class, you have to come up with a way to serialize it. How are you going to represent that on the wire when you're going to send it over? So you have to. This is like a big, to me, as a Clojure programmer who's used to just saying I'm just working in maps and other data types. I can just serialize it to disk if I want to. It's so freeing. I don't have to worry about writing all that stuff myself. Plus, they have known interfaces. So if I find that the hash map, I get a hash map, I know what I can do on it, right? I don't have to go look up the API docs and what are the methods on this object. I can print it out at the REPL and just see, oh, here are the keys that it has, and these are the ones I want to access, right? There's just something freeing about that. It gives it like that immediacy. It's sort of like, it sort of feels like if you had an object-oriented system, it would be like, okay, you have all these different components and each one has its own user manual and you have to read all the user manuals and before you can start using the device. Each class is like its own little device type. And in functional, it's much more like, okay, there's four main things, four main components. You learn how they work, and now you're putting them together in different ways. It's like there's four kinds of Lego blocks, and you just kind of figure out how they work together and how to use each one individually, and boom, You're done. Instead of having like all these like components that are all custom and all bespoke, you have 4 Lego blocks, and you can create millions of combinations of when you have those. And then the last thing is you can always write functions to sort of canonize or specify how you want to use the object. So the data. I've had another episode, like, I don't know, 8 months ago, where I said define your interface first. And a couple people, not a lot of people, I think I was being pretty clear, but a couple of people were like, what? That's like object-oriented programming. How can you do that? You want to leave the data as data. I'm not saying when you write an interface, you're changing the way you access the data at all. I'm just saying, that's what I'm saying, that each context is going to use that data in a different way, and at some point, you can start taking all that in one context. You can start saying, this is how this context wants to interpret this data, and you write it into functions. And then you call those functions instead of duplicating that functionality all over the context. Right? That's all I'm saying. But by thinking about the interface, and especially if you've got different contexts that you can foresee having, that those interfaces will influence the data and how it will be structured. That's what I'm saying. You can always write functions that sort of that define how this context is going to interpret this data. That's an interface. It's just that each context has its own interface, and it's still data. Like in Clojure it's still a hash map. In JavaScript, it's still just JSON. Okay, it's still just data. But this context will say, well, I'm looking at these 4 keys, and I need to manipulate this part of it. And so the interface can come later. You can defer it, or you can think about it up front if you want to. It's up to you. All right, so how do we do this? All right, so just use data. Use the existing data structures that you have available in your language. Or if it's something like Haskell that makes it really easy to define new data types, then use those. Okay, so Rust, Haskell, Elm, these are just great languages for defining new data types. But they're data types. They're not classes. They're not, objects. They're data. Start thinking of your data not as like the current value of something, but as immutable facts. It's like if someone wrote down a fact on a piece of paper, and then boom, that's it. That's the fact. And what if they were wrong? Well, the fact is they were wrong. Okay, so you want to remember that. Okay, if they were wrong, that's the problem with computers is garbage in, garbage out. But you don't want to just overwrite what they said, because what they said is what got recorded down. And what you need is a new event, a new piece of data that represents the correction. Okay, so it's a different. It's like a little new connection you got to make. New way of thinking about it. That a fact is a fact, and data is just writing down the fact. Okay, and then another thing is that as these pieces of data evolve over time, as your software evolves, they're going to change. Like the data types are going to change. The data that you represent is going to change. So one thing that really helps with that evolution is to treat the data like assume the least about the data as possible. Okay, so you're going to have to assume some things, right? Like I can't calculate the area of this circle if I don't have a radius. Okay, I just can't calculate it. But you don't need to know the color of the circle to calculate the area. So don't look at the color. Okay, just look for the radius. And as it evolves, more keys will be added, and that function will still work. More data will be added to that piece of data, but the radius will still be there, and so it will still work. That is one way of protecting, like future-proofing your code. You don't need to. You shouldn't look at stuff that you're not interested in at that point in the context. And so the other thing is, if it has keys that you don't need, then just let it be. Just, okay, you can pass me anything else, but as long as I have that radius, I'm good. Okay, so don't like tightly validate, like I need a piece of data with only a radius, because then you're not allowing for future evolution. Just let it be. Let it pass through. I'm just going to look at the radius, whatever else is in there, whatever. That's a tip. All right, so let me recap. Data is data. It's just facts about events. It's in the dictionary. Look it up. And it's immutable. A fact is a fact. If you ask someone a question and they answer it, the event is the answering, and the fact is what they said. They might have been wrong. They might have changed their minds. But that time that they said that thing, it happened. And that's the only thing we can really rely on. Unless we ask them again in an hour, what do you think now? That's the thing that's going to circulate through the system. We can't know what's inside their head when they change, right? Okay. You're probably already doing this, that you're doing it between, an API boundaries. So this system talking to that system, this service talking to that service. You're sending JSON, or you're sending XML or some other data format, and it's just data. And when you send it or when you get it, it's just data. And functional programmers just extend that more. Like the whole system is just data. Why not? I think it has a lot of benefits. I certainly enjoy them. Now, encapsulating your data also has benefits. Okay, it does. It's sometimes nice when you have a really expressive, powerful interface to that data that comes along with the data. It's nice, but it also has some cost. Like you have to write your own printer, or reader. You have to learn the interface. You have to read the manual. You have to understand how it's working. You have to trust it. That's another thing. The benefits of not having to do all those things, it's much faster to get started. All the getters are known. Number two, they have all the printers and the readers and a known interface. Number three, they already participate in all of the existing stuff that those data structures can participate in. And you can always add an interface, like programming. That's what programming is. You're just making functions that interpret that data in different ways. Right, so you need immutable data, and then the big one is just if you don't care about the color, do not look at the color. Okay, just look at the radius if you just want to calculate the area. And number 2 is don't worry if someone passes you in something you don't understand. You don't need it. Don't worry about it. Just, goes to the next function, just how it is. And so, one thing that we do in Clojure a lot, which I think might scare some people, but we really benefit from it, is you could have a function that takes this circle data structure. It's a map. It has a radius key with a value. And we're ignoring all the keys, but we write a function that takes that map, calculates, it takes out the radius, and then puts a new key in that is the area. Okay, so area and 100. So it multiplies the radius times pi r squared, and then it does and puts it into the map. Okay, we do that sometimes. We're like, I just want to calculate the area one time. I'll just add it to the map so I don't have to calculate it again. And so if something needs the area, it's in there. But what we have to do is remember to to return the modified map from that function, right? Because it's immutable, we have to get it out of the function somehow. So we don't just return a map with radius and area. We return the original map with the area. Okay, that's another benefit, another tip is always be adding data. You can always have more data. Okay, so I thought of a cool assignment for this. If you're an object-oriented programmer and you're used to sitting down and making classes and designing these interfaces, what would it be like to just pass around the data? What would that look like? Where would you put all that functionality that was going into the methods? And what if you didn't have to modify the data? What if it was immutable? What would that look like? Where would you put that functionality? And what functionality wouldn't you need if you didn't have to modify it? And it's just kind of a thought experiment, because this is what we do in functional programming, and it's hard for me to. I don't think I could sit here and just tell you you're wrong, but I think that there's existence proofs that there's a lot of functional systems out there that are doing what I'm saying, that are just operating on data, big systems that have been in production for a long time. Just think about what would it be like if you didn't do that. Not asking you to change your opinions or anything. Just thinking from a different perspective. All right, if you've liked this, wow, it's gone on pretty long. I'm already at 33 and a half minutes. If you've liked this, please do me a favor and subscribe, because then you'll be notified when other things very much like it come out. If you think I went too long on this, if you think it's unimportant, if you disagree, if you agree, I would love to hear from you. I just want to meet people. I want to meet people. I'm broadcasting these things out here, and I want to know that people are listening. I am not always confident of what I'm saying, even though I believe it. Once you say it, you're like, people might disagree with this, or I've never talked to anybody about that. I wonder what they say. So please tell me what you think, because that's what I'm doing here. I'm trying to engage with more people, and that's why I'm broadcasting. Okay, so you can email me at eric@lispcast.com, lispcast, LISPCAST. You can find me on Twitter. I'm at Eric Normand with a D. And I'm also on LinkedIn, so find me there. And take care. See you next time. Thanks for being there.